And finally, we'll dive into solving equations. We'll use the techniques that we explored when we were just looking at expressions and apply these now to equations. So we actually accomplish something here. We get to solve for a variable. Questions originally will look like this. We've got some groupings in the form of brackets or maybe in the form of fractions. We'll move into more complicated rational expressions after this, but we'll develop the tools that we'll need using questions like the ones on this slide. Each of these we'll tackle in exactly the same way. The first step in solving an equation is to undo any groupings. So looking at this first question, let's try that. So I want to use distributive property to multiply -6 by 2 and by -3x. So I get 3 minus 12 plus 18x is equal to x minus 5. Groupings are undone. Our next step is to collect any like terms. So 3 minus 12 is -9, plus 18x is equal to x minus 5. And now I want to make sure that all of my terms that have x's are on the same side, and any terms that don't have x's are on the other side. Don't forget the golden rule of equations. What I do to one side of an equation, I must do to the other. But that's actually quite powerful, as it lets us move terms from one side to the other. So I'm going to move the x on the right-hand side over to the left. Because I've got a positive x on the right-hand side, I'm going to subtract x from both sides. So I'll squeeze in a negative x over here. The notation you use for this isn't nearly as important as writing down the correct solution. So my next line is going to have a -9 plus 17x is equal to, well, x minus x is 0, is equal to -5. And many of you may have moved that -9 from the left-hand side to the right-hand side in that same step. And you're welcome to skip many of these steps here. How do we move the -9? Well, because it's negative, I'm going to add 9 to both sides. Maybe I'll squeeze that in here. -9 plus 9, and I then have -5 plus 9. Again, as long as you're doing the same thing to both sides, you can add, subtract, multiply, or divide. In fact, we'll see that we have even more options, as we can take the square root of both sides or the cubed root or raise both sides to the same power. But we're not dealing with powers just yet here. All right, so my next line, -9 plus 9 is 0. So I have 17x is equal to -5 plus 9, therefore 4. So to recap, what we first did was open up any groupings, open up any brackets, and groupings could also be fractions, so we'll remove fractions in our first steps as well. Then I moved terms around so that like terms were on the same side, so all the terms with x's on one side, all the terms without x's on the other. And then as a final step, I need to remove the coefficient of 17 from x. 17 is being multiplied by x, so to remove it, I'm going to divide both sides by 17. This works because 17 divided by 17 is 1. So I'm left with x on the left-hand side and 4 over 17 on the right-hand side. A note about this is the final answer because 4 over 17 can't be reduced further, but do make sure that you reduce any fractions to their lowest form. And further, feel free to leave these fractions as improper fractions if necessary. We tend not to write these as mixed fractions. So for example, if the answer had been 17 over 4, we'd be perfectly happy leaving it in that form. Okay, let's tackle the second one. As we go along, I will start to skip some steps, but feel free to use as many or as few steps as you'd like. Here we've got two things going on, two types of groupings. I've got some brackets in the numerator, and I've got a fraction. The entire left-hand side is divided by 3. We can get rid of those in one step. How do I get rid of the 3 in the denominator? Well, because the left-hand side is being divided by 3, you'd use the opposite action, and I'm going to multiply by 3. Of course, what I do to one side, I need to do to the other, so I'm going to multiply both sides by 3. Works nicely, as 3 divided by 3 is 1. So what's left over here is I've got 4x minus 2 times x, so minus 2x, and then minus 2 times negative 4. Negative 2 times negative 4 is positive 8. And on the right-hand side, I have 8 times 3 is 24. Collecting like terms on the left-hand side gives me 4x minus 2x is 2x. And I think in the same step, I'm going to move the 8 over to the right-hand side. How do I move it? Well, because it's positive 8 on the left, I'm going to subtract 8 from both sides. That leaves me with 2x is equal to 24 minus 8, or 2x is equal to 16. One last step that I need to do is to remove the coefficient of 2 from the x. Because 2 is being multiplied by x, I'm going to remove it by dividing both sides by 2. Works nicely, and I'm left with x is equal to 16 over 2, which is 8. How do you know you're right, by the way? How do you know that x, in fact, is equal to 8? What does that mean? Well, it means that if I substituted in an 8 for the x's in the original equation, the left-hand side would be equal to the right-hand side. So that's how we could check. We're not going to check with these, but I encourage you to do a couple of them. So now we get into slightly more interesting fractions. This is going closer to what we'll look at with rational expressions in a few slides. What I notice is that I do have some groupings here, in that I do, in this third question, have a 5 over 7, 5/7 x. I have a fraction. Let's get rid of that immediately. One thing I could have done is taken this 5/7 x and the 3x, move them to the same side, making sure I have those two terms, those like terms on the same side, and then done the required addition or subtraction. But adding and subtracting fractions is a fair bit of work, and I prefer to get rid of the fractions immediately. And then I only have terms with numerators to deal with. So the goal here is to get rid of the grouping, to get rid of the 7 in the denominator. In the previous question, we got rid of the 3 in the denominator by multiplying both sides by 3. And here we'll get rid of the 7 by multiplying both sides by 7. We do have to be a little bit careful here. Stop. Okay. Start. Here, the 7 is being multiplied by 5/7 x, but also by negative 4. In other words, be careful that you are using distributive property. So it might be best if we write it out. We'll take the 7 and multiply it by 5 over 7x, and also multiply it by the 4. So we'll subtract 7 times 4. And on the right-hand side, we have 3x times 7. Maybe just for uniformity, I'll write it one more time separately. So you can see that every single term in the equation is being multiplied by 7. So another way to think about it when you think of multiplying the left side and the right side is simply to apply that multiplication of 7 by every term. It means exactly the same thing. What it allows me to do is to see very clearly that it's only that 7 that's canceled. 7 divided by 7 is 1, so I'm left with 5 times x, or 5x. I do have to take that 7 and multiply it by the negative 4. 7 times 4 is 28, so I have negative 28. And on the right-hand side, 3x times 7 is 21x. What I like about this technique, and we'll see this for all questions going forward, anything that has fractions, is that even though we have one line, this line here, that is often a little bit more involved, once we're past that, our question is fairly straightforward. We don't have any fractions remaining. All that's left for us to do is to collect some like terms. Well, I notice here that the negative 28 is already by itself. It's the only term without an x. It's on the left-hand side. So why don't we move that 5x over to the right? It's positive 5x, so I'm going to subtract 5x from the left-hand side and from the right-hand side. So I have negative 28 is equal to 21x minus 5x, or 16x. The only thing left for me to do is to divide both sides by 16. So now we've isolated x, and I almost have my final answer. I'm going to write it in the other way around. So I'm just going to have the x and the negative 28 over 16 switch sides. Negative 28 over 16 can absolutely be simplified. What are they both divisible by? Well, they're both divisible by 2. That would give me 14 over 8. So they must both be divisible by 4 because I could divide 14 over 8 by 2 again. And that is the largest number that goes into both. 28 divided by 4 is 7, so we have a negative 7 in the numerator. 16 divided by 4 is 4. So our final answer is x is equal to negative 7 over 4. And again, we'll leave it as an improper fraction, as long as it's in reduced form. Okay? So let's apply exactly that same technique to this final question. Our goal is to eliminate all groupings as our first step, which means we want to eliminate the 8 and the 2. What do I need to multiply by to eliminate the 8 and the 2? If I multiply the left side and the right side by 2, I wouldn't quite get there, because I'd have 2 times 5/8, and then also 2 times 1/2 x equals 4 times 2. So that almost works because these 2's will cancel and I'll be left with an x, but 2 and 8, while they do simplify, would leave you with a 4 in the denominator. So that's not quite going to work. So rather than multiplying both sides by 2, what happens if I multiply both sides by 8? Left side and right side. Or I could simply write this as the entire equation being multiplied by 8. So you'll see that as well. Taking the entire equation, multiplying it by 8 is the same as taking the left side and the right side and multiplying by 8. It's essentially one step more of distributive property that we have to do. And then we end up with 8 times 5/8 plus 8 times 1/2 x is equal to 4 times 8. Let's see what happens here. So remember, we're following order of operations here. I'm doing multiplication before any addition. I'm working within terms. I have 3 terms here. I'm working within terms before I add like terms. That's why I'm canceling first. 8 divided by 8 is 1. 8 divided by 2 is 4. 4 in the numerator. And there are no fractions on the right-hand side. So what do we have left? From the first term, we have a 5. From the second term, I have 4 times 1x, so positive 4x. And on the right-hand side, 4 times 8 is 32. So again, we had one line that was a little bit more involved, but it simplifies our equation dramatically. And we've got 4x. I'm going to subtract 5 from both sides. That leaves me with 27 on the right-hand side. Dividing both sides by 4 gives me 27 over 4.